Hello, we're going to do 137 and 138. Both have to do with distributions. One is a Algebra 2 question, so let's take a look at this. Algebra 2 question. They give us the weight of a population, so it's a full population that's normal, of male gray whales. So this is our gray whale distribution. The mean is 18,000. The standard deviation is 4,000. So I'm just going to show one standard deviation here, 22,000, 14,000. So 68% of male gray whales are around 18,000 plus or minus 4,000. So between 14 and 22,000. Then we're comparing to another distribution of a population of humpback whales. So I'm going to call that humpback whales, gray whales, humpback whales. These are mean weight of 30. So this type of whale is heavier on average. It's a different type of whale. Kind of like if I compared a barracuda to a mullet. Two totally different fish. Two totally different average weights. Now, the average humpback is that plus or minus 6,000. So the typical humpback is between 24,000 and 36,000, 68% of those humpback. So here's my two population distributions. And now they're asking something very special. They're saying a certain adult gray male weighs 24,000. So I basically know this. That's a pretty hefty gray whale, right? Because he's more than one standard deviation above the mean. And then they've asked me, this whale would have the same standardized z-score. So I know that this z-score is something greater than one z-score, right? And so they're saying this whale would have the same standardized weight z-score as an adult male humpback of what weight? Okay, so you don't know what this is, but you're saying what would be a similarly large-ish humpback whale so that they would have the same z-score, something a little greater than one z-score. So now let's take a look. You're going to do AP statistics. That's our Z calculation. So the actual weight of this gray whale is 24, and we would predict on average he'd be 18, so he's a little more than that. Standard deviation of 4. Do some quick calculations here. So that's actually 1.5. So it is greater than 1. It's exactly 1.5 Z-score. And so if you knew this humpback whale was equally large for his breed of whaleness, we can do the same thing, AP statistics. So his actual value, we don't know. So we make X what we don't know. We would predict a humpback whale to be 30. And the standard deviation of humpback whales is 6. And so we're going to cross multiply to solve. So we take here, we do this, do this. 6 times 1.5 would be 9, x minus 30, add 30 to both sides, I get 39. What do you know? That's what my answer was, 39,000. Let's check out the next question. Two distributions again. But this is a different type of question because it says sample mean. So this is a distribution of the samples. So when we're taking a distribution of a sample, we have a standard deviation of this, right? And the general rule states that as n increases, the standard deviation decreases because I think it makes sense that when we divide a number by an integer, the number gets smaller. And that should make sense. So if n is 100, I'm dividing whatever my standard deviation is by 10. If n is 400, so the square root of 400 would be 20. Notice this would be even smaller of a number. So as n increases, so let's look at the spread of this data. It looks like the standard deviation here is pretty small. If I'm just kind of judging by the picture, it looks like the standard deviation might be somewhere around 1. Okay, because it's all squished together here, distribution 1. And now when I look at distribution 2, it looks like one standard deviation would be something more like 2. So that's a larger standard deviation. Again, it says as n decreases, standard deviation decreases. So it looks like standard deviation, if this was my original one and this was my new one, as standard deviation decreases, n increases. This one has more n. Now let's read. Sample size 1 must be greater than sample size 2. And that's exactly what we are talking about here. So we're definitely going to pick B. Thanks for joining us.